everyone. Today's goal is to find angle measurements in polygons. The first thing we're going to talk about is a polygon. What's a polygon? A multi-sided shape. Usually a polygon will end in the term gon. We know a lot of types of polygons, pentagon, hexagon, and so forth. But then we start getting some weird numbers like 11. Does anybody know the name for an 11-sided shape? It's an 11-gon. What's a 20-sided shape? We just say 20-gon. What if it has n number of sides? N-gon. That n would represent a variable, meaning we don't know how many, it's n number of sides. So first off, let's start off with a simple shape and talk about its diagonal. So let's start off with a pentagon. Now there's a pentagon. We're going to talk about its diagonals. First one, we're going to talk about diagonals from one vertex only. So make one vertex bold. Now from that vertex, I'm going to draw my other diagonals. What's a diagonal? A line that is not straight? From where to where? Okay, so a diagonal is a line segment that goes from one to a vertex on the other side of the shape. There's one diagonal drawn. I can actually draw one more diagonal on the shape. Now it has two diagonals from that vertex. So when I'm only focused on one vertex, I notice it divides the shape into some special shapes. Those are what shapes? Those are triangles. There are three triangles when I'm just focused on one vertex. Well, I could do something differently. Instead of focusing on one vertex, I could focus on all vertices. So here's another pentagon, and we're going to focus on all the diagonals in the whole shape. So that means let's start with that same vertex earlier. We have one, we have two diagonals from that vertex. If I go around to another vertex, I can draw some more diagonals. We're going across the shape to another vertex. So there's three diagonals, four diagonals. Can I draw any more? Yeah, I can draw some more. From this vertex, I would have 5 total diagonals. And that's when I go from multiple vertices instead of just one vertex. The one I kind of want to focus on, though, is this one, focused on one vertex, because this will help us generate a formula. So first off, let's talk about these trivial shapes. Triangle. What's after a triangle? Quadrilateral. After that, pentagon, hexagon, and so forth. Now, a triangle has how many diagonals? A triangle has how many diagonals? 0 diagonals. But how many triangles are pictured? It has one triangle in its picture. A quadrilateral, how many diagonals does it have? From this vertex, just one vertex is what you're focused on. How many diagonals? It just has one diagonal, creating how many triangles? 2 triangles. Well, we just did a 5-sided shape. It has 3 triangles. What do you think a 6-sided shape will have? 4 triangles. Now let's think of this. Inside angles on a triangle add up to what special number? Do we not remember? 180. 180 degrees for a triangle. All right, well, you go one shape bigger. Quadrilateral, this one you should know. That sum is 360 on the inside angles. Now, a pentagon is actually 540. and then a hexagon at 720. Now there's a pattern here. There's a pattern here. What's going on in this pattern dealing with our triangles, quadrilaterals, pentagons, and hexagons? We're adding triangles, so we're adding on 180. So it's a formula, though. It's not, a triangle has three sides. We don't say 3 times 180 gives us the total. What times 180 gives us 180? But how many triangles times 180 will give us this final answer? But you don't want to go through and draw these pictures every time, though, so we need to come up with a formula. So let's think. What relates the number of sides on a quadrilateral to this number 2? How do you go from there? How do you go from 4 to 2? Minus 2 is one way, or divide by 2. Now over here, how many sides are on a pentagon? 5, and how do you get to 3? Subtract 2 is the common theme. So we take the number of sides in, subtract 2, put that in parentheses, then multiply by 180. What we just did is we generated the theorem 8.1. It says n minus 2 times 180. This will give us a special number. This number, I would write this out to the side if I was you, is the sum of the interior angles. The sum of the interior angles always comes from this formula, n minus 2 times 180. Are there any questions there? We're going to be using this in a little bit. Let's go over this next one. You already know this answer. If you read the corollary to Theorem 8.1, it says interior angles of a quadrilateral. We just wrote that out to the side. What's that sum? Well, we can go to the n minus 2 times 180, but if you took good notes, what did we write to the side of the word quadrilateral? 360. You should remember this. Just like you remember 180 for triangles, 360 is for quadrilaterals. Those are numbers you should remember without having to do this formula, n minus 2 times 180. Circle is not a polygon. It doesn't have any straight sides. It has curves, and that's one thing that violates the definition of a polygon. Now we're going to try example 1. In example 1 it says, find the sum of the interior angles in a convex hexagon. Underline these key words because this will tell you which formula to use. Later on it will get harder because we're going to have other terms. This one says sum interior angles. Well, we know its formula. It's n minus 2 times 180. Well, what is n in this case? What's our n? Oh, a hexagon is how many sides? 6-sided shape. Plug the 6 in for the n. And this is some simple math now. What is 6 minus 2? It's 4. 4 times 180, 720. And that's also a number we talked about earlier. I'm not making you memorize this one because you can use the formula for this. So the sum of the interior angles, once again, is 780 degrees. Let's go to the next one. Example 2. On example 2, it says the sum of the measures of the interior angles of a convex polygon is 1,260 degrees. Classify the polygon by the number of sides. In that first sentence, what are our key terms? Sum, interior angles. We know that formula. What is it? N minus 2 times 180. If you write a bunch today, you will memorize it by the end of the day. This equals that sum. Are there any numbers we can substitute into this equation? Yeah. What can we plug in? Where does that go? Where does that 1260 go? Oh, it tells us that is the sum. It is 1260. So let's substitute that value. And Here's some easy math if you remember your algebra skills. What should we do first? There's two options, actually. Divide by 180 is the best step. That'll cancel our 180s. We're left with n minus 2 equals, calculator people? To get n alone, how do you get rid of that minus 7? You add 2 to each side. And we get n. Have we answered the question so far? The question says what keyword? Classify. Nine-sided shape is a nonagon. N-O-N. Any questions? Good work. Let's do example 3. Getting a little more challenging. So in this picture, it says, find the value of x in the diagram shown. What kind of shape do you see there? It's a quadrilateral, meaning it has 4 sides. We know the inside angles on a quadrilateral should add up to 360. So the sum of those inside angles should be 360. That means we need to add up all those angles to get 360. That's what we're going to do right now. So the first one, we'll put our unknown x. The second term, we'll say is that 135, 112, and 71. Simple algebra steps. Combine the like terms. What do we get? 318. To get x alone, what do? We subtract 318 from each side, and we get x is 42. So that angle, that missing angle, is 42. Any questions? All right. On example, or checkpoint 1, it says, find the sum of the measures of the interior angles of the convex decagon. Deca means what? Deca means 10. So this is a 10-sided shape. I'm going to say n equals 10. Sum interior angle formula, once again, is n minus 2 times 180. 10 minus 2 times 180. 10 minus 2 is 8. And 8 times 180 is 1,440. Who all got that one right? Good job. Pretty much everybody. All right, checkpoint 2. Slightly harder, not a whole lot harder. The sum of the measures of the interior angles is 1,620. Classify by the number of sides. So this one is just like the example. This number right here goes in for our sum. So we'll say n minus 2 times 180 equals that sum, 1,620. First step would be divide by 180, just like earlier. They'll cancel on the left side. You'll be left with n minus 2 equals 9. To get n alone, you got to add 2 to each side, and you'll get n is 11. An 11-sided shape is called an 11-gon. That's one of the weird terms, 11-gon. Good job. Now, number 3. I saw a lot of interesting answers on number 3. Number 3 says, use the diagram at the right to find K and L. We want their measures. Whenever it says little m, that means find the measure. Give a numerical value. So first thing, you've got to come up with a setup. What have we learned so far about a 5-sided shape and the sum of the interior angles on that one? The sum is 540. Some people have already remembered that from earlier. So we're going to say everything adds up to equal 540. Everything inside adds up to 540. So these are our unknown values, though, in the picture. We'll call this value for K, we'll call it X. Well, if K is X, how big should angle L be? Are they the same or different? Oh, that congruent mark means they are the same size. So they are both X's. Both terms are X's. How many total X's do we have in our picture? We have 2 X's. We can then add up the other terms. We have a 68, we have a 105, and we have a 109. On the left side, we can combine the like terms, which are those three-digit numbers, 109, 105, oh, and 68. Oh, and that's 282. Good help. All right, I'll change that. Thanks. Two steps remaining. It's a two-step equation. Subtract 282, and you get 258. Getting very close to our final answer. Divide by 2. 129. So don't leave your answer as that. It wants to know measure of angle K and measure of angle L. So we need to state that. Measure of angle K is 129. Measure of angle L is also 129. Who all got that one right? Yeah. Okay. Not as many, but still pretty good. Pretty good. That was a little more challenging. I'll go ahead and tell you. These are great problems for the test. This stuff is identical to what's on the test. These are good problems. The next theorem is Theorem 8.2. It deals with exterior angles. So I'm going to show you kind of a picture that will show this theorem a little bit better. Exterior angles are actually really easy if you can visualize this picture. So I'm going to pull up a shape. Maybe let's do a hexagon. So I'm going to draw a hexagon. Now on this hexagon, I have to talk about exterior angles. If I draw an angle outside of the shape that looks like this, is that angle where I put a question mark an exterior angle? I hear yes a lot because it's outside of the shape. But actually, if you look, it's vertical to the inside one. It is not an interior angle. Sorry, it's not an exterior angle because it's the same as the interior. Those are not the ones I want to focus on. I want to focus on these over here. And really, I only need one of them. I don't need to look at both of those exterior angles. So I'm going to erase one of the angles and just focus on this single exterior angle right here. To generate those around the other vertices, you just follow along the side, get to the vertex, and make the angle in line with one of the other lines. That's an exterior angle right there. Follow along the side, stop at the vertex, and go off of that vertex along the line with the other side. Kind of hard to explain, but just follow the side, stop. If you continue that process along the outside, you'll see that you have how many exterior angles? Okay. I'll do that in a little bit too. So we have 6 exterior angles. Check this out. I can grab these exterior angles now. And I'm going to put them all together. And what do you think is going to happen when I put all these together? They're going to be in the shape of a circle. Okay. Getting really close. So when you put all the exterior angles together, you'll see that all the angles add together add up to be a full circle, and a full circle adds up to 360. This works on any shape. This works on any shape. If it has a million sides, there'll just be a ton of tiny little angles still adding up to that 360. One student recommended this. They said instead of going back upon itself, just do this. And I like this. If you do that, then you have the exterior angle. That works also, but it wouldn't have worked for my picture. I wouldn't have been able to copy them and put them all together. But that works if you want to be able to see your exterior angles like that. That works if you're drawing on your own piece of paper. All right, let's go back to notes. What did we just learn about exterior angles on any type of polygon? They always add up to 360. So write this out to the side. Exterior sum is 360. On any polygon, the exterior sum is 360 degrees. Example 4 is one more. We'll get to try this out. This one says, find the value of x in the diagram shown. These are all exterior angles. The sum is what magic number? 360. Substitute that into the equation. And now we can put the other terms around the outside. We'll start with angle x. We have 89. We have 2x. And we have 85 degrees. From here we can combine like terms. 1x plus 2x's is how many? We get 3x's. And then we have 89 plus 85. 174. Now it's a two-step equation. Subtract 174 and then divide by 3. What do we get? We get x is 62. A common extension on this problem, though, will be to substitute back in. That means that this angle x up here would be 62 degrees, and 2x's would be 124 degrees. Are there any questions? All right. Example 5. It's our last example. And this is the most challenging problem in the section. Guarantee it. It has multiple parts. But if you really understand polygons and the formulas we've done so far, it won't be that hard. Example 5 says, the base of a lamp is in the shape of a regular 15-gon. What does regular mean? All sides and all angles are equal. That's a key term right there, regular. First step, we got to find the measure of each interior angle. That's a new term we haven't seen yet. Each. We've been focusing on sum so far. Now it's each. And then we want to find the measure of each exterior angle. We're going to break this down into two sections. We'll say the first section is part A. Part A deals with the interior angles. What formula goes with interior? N minus 2 times 180. Well, this is 15 sides, so that's 15 minus 2 times 180. 15 minus 2 is 13. 13 times 180 is 2,340. That's the sum of all the inside angles. But it doesn't want the sum, it wants each. What should we do at the end? Oh, we take 2,340 and divide by the number of sides, or the number of angles, and we get a total of 156. That's how big each interior angle is. Not too bad. Part B is actually simpler. Part B deals with exterior. What did we learn about exterior earlier? They always add up to 360. We don't even have to guess on that number. We should know it. So we should take 360 and do what? Divide by 15. And we get a total of, so each exterior angle is 24. This shows the more sides you add, the smaller that angle will be.